Hello, we're really excited to be sharing here today. We're going to be talking about Data Prepper and using it for ingestion into OpenSearch. Like Sean said, I'm David Venable. I'm a senior software engineer at Amazon Web Services. I'm also a maintainer on the Data Prepper project.
And good morning, everyone. My name is Krishna Kondaka. I'm a senior software development engineer at AWS. I'm also a maintainer of Data Prepper.
We're excited to be sharing why we believe now is the time for you to start using Data Prepper. I'm going to talk a little bit about our agenda. So first I want to introduce what Data Prepper is. Then we're going to talk about some of the core use cases that customers have for using Data Prepper and some of the capabilities it provides. We're going to spend most of our time on this part. We're also going to be talking about how Amazon is running Data Prepper at scale with something called a new service called Amazon OpenSearch Ingestion. We'll have a brief comparison to Logstash and then some about how you can get started. Let's jump in. Data Prepper is a community-driven open source project. It's part of the OpenSearch project and is Apache 2.0 licensed. Now, we originally created Data Prepper to solve a usability use case. So a lot of people were wanting to ingest observability data into OpenSearch. So distributed traces, logs, and even metric data. And what we found is that a lot of customers want to use Data Prepper for more than that, other analytics use cases as well. And so we've been putting more effort towards that and have even started growing some options for doing search use cases. So Data Prepper provides a number of capabilities, and one of the ones we're going to be sharing about quite a bit today is the idea of stateful processing, how Data Prepper can process data as you're receiving streaming data into OpenSearch. So at Amazon, we've been running OpenSearch for a while, and we've learned a number of things through this. And these have kind of guided how we reached the point of creating Data Prepper and what we've been aiming for. So we've seen that customers want to be able to improve the costs of running OpenSearch. And Data Prepper will help by providing data duplication, filtering of data, sampling. We can also route data to different geographic regions. So if we have data that perhaps needs to be in one spot, route to lower cost solutions. So a lot of customers are interested in writing data into S3 as well to have data which is cheaper to store than in your OpenSearch cluster. There's also a need for data quality. So as we get data in OpenSearch, we want to be sure it's ready so that we can have actionable insights on that. We don't want to have to be looking at our OpenSearch cluster and try to figure out how to manage the data. We want it generally normalized and in a good state. So Data Prepper will help through enforcing standards and allowing you to adopt schemas. We all care about our customers' privacy. This is a major component for many companies. And with Data Prepper, you can obfuscate and protect your customers' data before you put it in OpenSearch so that you know you're not storing private data. This is also where you can control routing so that, say, you want to store some customers' information in a geographic region because of compliance laws. And then also streaming data analytics. So we want to be able to offload some of the work from our OpenSearch clusters and provide certain analytics before putting it into OpenSearch. We're going to talk about some of that today. And with that, let's keep moving on. So now I'm going to talk some about how Data Prepper works. It basically consists of one or more pipelines. Now, a pipeline is going to pull from some external source, or you can have an external source push into Data Prepper. From there, it goes into your pipeline's buffer, and then you have a set of processors. And this is where a lot of the great work happens. This is where you can do your filtering. This is where you can have your transformations, modify the data for your needs. This is also where we do our stateful processing as well. And then finally, we send it out to an external sink. And one of the major sinks, of course, is OpenSearch. So one of our major goals is to write to OpenSearch. And we've put a lot of emphasis into writing to OpenSearch really efficiently. If you got to listen to David Tippett's talk yesterday, our OpenSearch sink uses a lot of the principles he was talking about for efficient ingestion into OpenSearch. Data Prepper also supports conditional routing. So you can send all of your events to one or more sinks, but you can also conditionally route some of them. Like I said, perhaps you want to key off of some geographic code in your data, and then you can send it to one OpenSearch cluster or another. Or perhaps you want to send your 200 logs to OpenSearch, and then maybe your 400 to another OpenSearch cluster. One of our major use cases is log analytics. This is an important aspect for observability. And this gives our reference architecture for using Data Prepper for observability and log analytics. In it, we recommend you put Data Prepper in front of your OpenSearch cluster, and you're going to have multiple applications running. These are probably your microservices that you have out there, and you probably have multiple machines for each of these. So for each of these applications, you're going to want to run FluentBit as a sidecar. It'll be collecting your log data, and then instead of sending that to OpenSearch, you can send it to Data Prepper, and now we can do our standard processing before going into OpenSearch. Your typical log line is going to look like this. There is something meaningful in there, but you might not know exactly how to make use of it. And so the first processor pretty much any log analytics pipeline will have is the Grok processor. And what it'll do is it'll extract the data out of here and structure your data for you. And so now you have something that makes a more useful document for querying in OpenSearch. So for example, you can see your 200 response code in here. Now, we started with the idea of grabbing your own application logs, but a number of customers came to us and said, hey, we've got these other services that are running adjacent to us that we really don't control, and we want to get logs out of them. In particular, a lot of these were AWS services. So customers running their services in AWS VPCs, they wanted to get their flow logs so they can get a sense of traffic coming in and out. People would also use an elastic load balancer to route data into their microservices. And so you could get a little more insight from your load balancer logs. CloudTrail and the web application firewall are another example. And so what we did was we added the ability to load this data from S3 and put it into OpenSearch. For log analytics use cases like these, where you have this constant stream of data coming in, we recommend that you use an SQSQ and an S3 bucket. So as these services, such as the VPC flow logs, are writing data into your S3 bucket, it's going to add a message to your SQSQ, which notifies Data Prepper, hey, let's load from this bucket and let's take it into OpenSearch. But we also found that there are customers that have their own custom process that's writing to S3. And perhaps it's even doing it on certain intervals rather than continuously. And so customers started asking us, hey, how can we use Data Prepper in this situation? And so what we added was a new S3 scan capability. And so you can configure Data Prepper to scan an S3 bucket periodically rather than wait on messages in a queue. We found that there are people wanting to use this for things like financial data that they're uploading into S3, or perhaps inventories of different kinds. We added this feature back in the summer, and we've seen some good adoption of it already. Now, with the logs analytics use case, we can help reduce your overall costs of OpenSearch. So one of the things that people want to do is filter out data or perhaps sample data. So as you get logs coming into Data Prepper, instead of sending all of them to OpenSearch, you can now send some of them to S3. And with this, you can reduce the overall cost of running OpenSearch, one, by reducing your storage costs, but also you can reduce the CPU needs. Perhaps you can make your cluster a little bit smaller by removing some of these logs, but you still have them there if you need them. And again, with those logs being in S3 and Data Prepper's S3 scan capability, now if you ever need to, you can pull those logs back out of S3 and put them into OpenSearch for ingestion or for analysis. So you might want to do this if you have an RCA or need to do some other sort of incident analysis, really go deep on something that happened. Not only that, but Data Prepper can write to S3 in the popular Apache Parquet format. And with this, now as you write your data into S3, you can use other tools to do ad hoc queries on S3. One of these is the new OpenSearch Spark connector, which is in OpenSearch. So now you can query that data in your S3 bucket, or you can use another tool like Amazon Athena. We've had a number of customers asking specifically about that one. I'm going to move on to the trace analytics use case. So we know that a modern web architecture really consists of many different services that are providing support for our customers. So as a customer or client makes a web request to an application, it really goes through multiple different microservices and travels around through those services. We love this as developers, but it does create a headache, which is, hey, how are these requests getting managed? Well, the industry standard solution here is to provide distributed tracing. And so in this, as your requests go through your applications, we can create spans of data, send those to Data Prepper, and then analyze that later. Now, the Amazon OpenSearch Observability plugin has fantastic support for trace analytics. Here you can see how it visualizes a single trace representing a web request going through your system. So you can see, for example, how long it took. You can see where there might be delays. For example, you can see one request in particular is taking a long time. And you can also see errors that occurred, like the ones I highlighted here. Not only that, but you can generate a service map. And this service map gives you a bird's eye view of your entire application, how all the pieces are fitting together. You can also use this to see where perhaps certain microservices are having high latency, or maybe where there's a high set of error rates. And this will help you know what to address within your system. My colleague Ani is going to be giving a talk at 1:15 over in Ballroom CD about the OpenSearch Observability plugin. I recommend you go check it out because he's going to be talking about a lot of these great features. This is our reference architecture for using Data Prepper and OpenSearch with trace analytics. So you have your applications running, and what you would do is instrument them with the OpenTelemetry instrumentation tools. So OpenTelemetry is another open source project, CNCF, and they have tools that can automatically instrument your application. So you can automatically instrument your Java applications or Python. And then you're going to also have the OpenTelemetry collector running as a sidecar. So it's going to collect all those spans of data from your applications, send those to Data Prepper, where we will do the aggregation and sending everything to OpenSearch. Now, as you can imagine, you get volumes of data from trace analytics. Now, one of the standard solutions for reducing such volumes is sampling. And this is actually really easy in logs, right? You get a log and it tells you everything you need, right? It's a 200 response. Okay, I'm going to sample this at 20%. With traces, it's a little bit different because every trace is actually made up of multiple spans. And these different spans are each coming from each machine. So in this case, we see, one of these middle layers provides a span to Data Prepper. This is only one piece of the entire picture of a trace. Now, all these spans are going to get sent to Data Prepper. We don't know the order, but what we want to do is collect all those spans and then make a tracing decision. And so the solution here is what's called tail sampling. In this Data Prepper pipeline, we have a tail sampling processor sitting before your OpenSearch cluster. And so in this way, you can sample your traces rather than sampling the spans. And so as a span comes in, Data Prepper holds onto it, and it collects all these spans that are coming in for a given trace. Once it has all the spans, now it has the full picture. Now it knows, okay, this is a 200 or this is a 400. Now I'm going to make my sampling decision. And then you can send a sampled bit of data to OpenSearch. So maybe you only want to send, let's say, 10% of successful responses to OpenSearch. You can reduce your storage costs and again, your CPU by ingesting less data into OpenSearch. And at the same time, send all that data to S3. So you have it later if you really want to get access to it at another time. With that, I'm going to hand it off to Krishna. He's going to continue talking about some of our capabilities.
Thanks, David. I'm going to talk about new features we added to Data Prepper. Most of these features are developed based on customer requests to provide data reliability, data durability, to protect privacy and reduce costs, and also add some new analytical capabilities. Many customers are already using these features. So let's start with them. So the first one I'm going to talk about is the percent sampling. So this is used to reduce the amount of data that you can store in the sink like OpenSearch. This is motivated by the fact that most of the logs are identical. I have a lot of duplicate information. For example, you can see these logs where they are identical except for the timestamp. So you can actually just send a sample of this and store a little amount of data rather than sending all of them. So data prepper implements this percent sampler as an aggregate processor action. You can configure what percent of the events you want to sample, and you can also do that conditionally. For example, I have an example configuration here. This configuration basically says that when the IP address is 1.1.1, sample that input, and only 20% of it is actually sent to the sink. And yeah, so the next one I'm going to talk about is rate limiter. Rate limiting is a very well-known strategy to control the amount of traffic. In case of data prepper, you can control the amount of traffic you can send to the sink, because some sinks may not be able to handle traffic that is sometimes very high or bursty. We can basically control it to make it easy for the sinks to handle them. So for example, let's say you have a traffic that's going at this like varying rates, and the sinks may not be able to handle very peak traffic or the bursty traffic. And then with the rate limiter, you can make sure that always a set amount of traffic is sent, and it may be buffered sometimes, but it never exceeds the specific load given by the configuration. So rate limiter is also implemented as an aggregate processor action. You can configure the number of events that you want to send. You can also configure what to do when you exceed that limit, and it can also be done conditionally. So this shows an example configuration for using rate limiter. In this example, IP address with 1.1.1 is rate limited to send only 100 events per second, and when that events exceed that limit, they are dropped. The other option you can use is to block. When you use that option, that excess data is buffered and sent in the next time window. This is very useful when you have some bursty traffic. Data prepper actually also added this feature to generate metrics. Metrics actually help you making decisions and also generate alerts. It can also reduce the amount of data that you store in OpenSearch, and also it's easy to visualize when you are seeing it through OpenSearch dashboards or Prometheus. Data prepper generates the metrics which are OpenTelemetry specification conform to the OpenTelemetry specification, and it can generate either count or histogram metrics. In case of histogram metric, it includes minimum, maximum value, sum, and count, and also individual buckets that customer can configure, and bucket counts will be included. And in both these cases, exemplars also included. So this shows basically how when you configure data prepper for using metrics, you can send metrics to OpenSearch, and you can send all the events to a low-cost sink like S3. This is an example of how a count metric is generated. If you have input of like say 5 different log statements, you can send all the events to S3 and just send one event to OpenSearch with the count and an exemplar. And exemplar can be used to actually will contain some context, and you can use that context to find the details of the actual events in the S3 if you really have to do it for root cause analysis and so on. Another important feature we added is anomaly detection. With the anomaly detection processor in the data prepper, you can find anomalies real time while ingestion is happening. For example, if you are getting data with a latency which is usually at around 10, but suddenly you have a higher latency, that can be detected immediately. So this shows the anomaly detector processor when it is configured in data prepper. Basically, all events are sent to OpenSearch. At the same time, all events are also sent to anomaly detector processor to detect any anomalies. If any anomaly is detected, it can be sent to a different sink, something like SNS, which can generate alerts or get notifications and take corrective actions. The anomaly detector processor in data prepper uses random cut forest model. This is the exact same code used by other AWS services like Kinesis or SageMaker or OpenSearch. It can detect anomalies in a number-based data in the input that's coming into data prepper. It, as shown previously, it can work on a single dimensional input, but it can also work on other modes like multi-dimensional and also high cardinal modes. I'm just going to give a brief examples of each of them. Take, for example, you have a service that has a CPU load of 15 on, say, Saturdays and 12 on Sunday and about 10 on rest of the days. And if you happen to see on Friday, you happen to see a load of 15, that can be detected only if you actually send information about the day of the week as well. So you have the two parameters now sent to the RCF model. You have the CPU load and also day of the week. With that two parameters, it can be more parameters as well. Basically, with these multiple dimensions, you can actually accurately detect anomalies. And another case is high cardinality anomaly detection. In this case, we may have to run multiple instances of the RCF model itself. So take, for example, data coming in with different IP addresses, and one IP address has, let's say, 1.1.1 has a normal CPU load of 10, and 2.2.2 has a normal CPU load of 20. If you happen to see a value of 20 with 1.1.1, it cannot be detected if you have like a single RCF instance running. By having two separate RCF instances, you can actually accurately detect independently any anomalies in each case. Another important processor we added is off-gate processor. This can help protect personally identifiable information like email address or phone numbers, social security numbers, and so on. When a service is running and it's generating logs, it may store one or more of this information in the logs, but those logs are eventually moved out of the service to some external storage like OpenSearch or something. Then you want to make sure that this information is protected. So the off-gate processor can make this easy. This is an example configuration for using off-gate processor in the data prepper. In this case, email and phone number are detected and masked with a mask character specified by the configuration. So with this configuration, if you send an input like containing an email address and a phone number, it gets changed to that. So this way, when the logs go out of your service to an external storage, you are protected with that information. Next thing I'm talking about is Kafka. We added support for using Kafka as source and sink in data prepper. Kafka is a very widely used open source distributed event analytics platform that is very widely used everywhere. And Kafka is not a permanent store. Data from Kafka is eventually actually put in something like OpenSearch or S3, and data prepper nicely fits in there. Before you actually send data OpenSearch, you can actually transform and enrich the data. Similarly, when the data is generated by something like OpenTelemetry, you can actually enhance and enrich before you send it to Kafka for further processing. So this just shows the example of where Kafka is used as a source to data prepper. Data prepper pulls the events and then sends them to OpenSearch or S3 as based on the configuration of the data prepper. Similarly, this shows the case where Kafka is used as a sink. The data is generated by an applications using OpenTelemetry collectors, and they generate traces and metrics. And we have some enrichments that you can do in data prepper that David already showed. And with that enrichment, you can send the events to Kafka for further processing. In the data prepper, we support 3 different types of Kafka cluster: the Amazon managed MSK Kafka cluster, and Apache Kafka, and Confluent Kafka. We support security, AWS IAM, and also username password security when communicating with Apache Kafka or Confluent Kafka. And data prepper also supports schema registry for data serialization and deserialization. We support AWS Glue and Confluent schema registry. In addition, topic configuration options are provided to actually configure topic level things like amount of data to process in each fetch, or auto commit or not, and the poll interval, and so on. Finally, I'm going to talk about durability, data durability. By default, data prepper is a very fast memory-based ingestion service which takes the events from external source. and then process them, enriches them, and then sends it to external sync. In this case, when the data is first received from the external source, we immediately acknowledge that data is received. But it is possible for the data to be lost before it is actually sent to the external sync in various places in the pipeline. So to solve this problem, we have added something called end-to-end acknowledgements. With end-to-end acknowledgements configured, you can actually make sure that the data is actually sent to the sync before sending acknowledgement to the external source. And in this, we support at least once delivery semantics, and also it supports positive and negative acknowledgements. So with end-to-end acknowledgements configured, data prepper, you can see that the control flow is basically the events are taken from the data prepper by the data prepper source from external source, and then it does processing and sent to external sync. And when it is successfully done by the external sync, we send the acknowledgement back to the data prepper source, which can actually send to external source. If it fails in anywhere, data prepper source gets a negative acknowledgement, which it can retry, or eventually it can send a negative acknowledgement to the external source itself. With that, I'm handing back to David for the rest of the presentation.
Thank you, Krishna. Amazon is running data prepper at scale at Amazon OpenSearch Ingestion. This is a new serverless data collector that Amazon added for the Amazon OpenSearch service. It is powered by Data Prepper. It uses clusters of Data Prepper for ingesting data into managed OpenSearch clusters. And so we've seen that the AWS team has certainly scaled Data Prepper to running 96 nodes and have been able to use that to successfully ingest data into OpenSearch clusters. I got a little bit of some of the information on some individual pipelines that we have. So we have some HTTP log pipelines where customers are generating about 12 terabytes a day of sending HTTP log data. And then we also found that a lot of customers are really interested in those S3 use cases we talked about. And so we'll have some customers who are generating up to about 70 terabytes a day into their OpenSearch cluster using Amazon OpenSearch Ingestion, which again is using Data Prepper underneath. Another question we get asked often is, what's the relationship between Data Prepper and Logstash? Well, Data Prepper is a brand new product. Our team wrote it about a couple years ago, and it has core support for OpenSearch. So its main goal is to support OpenSearch as well as some of these other use cases we talked about. And so if you use Data Prepper, we believe you'll get really good support from the maintainers and the community for using Data Prepper and OpenSearch. We also, like we talked about, focus a lot on this distributed processing and streaming data analytics. This is something we put a lot of effort into and make this a key component. So we talked about some of the things like metric generation and anomaly detection. We're doing all these things in a distributed manner. We also ran some performance tests against Data Prepper and Logstash. So for this first one, we ran tests using Apache HTTP logs. And so we were generating those logs, and we found that we were able to get 91% higher transactions per second than we got with Logstash. So that translated into 37,000 events per second with Data Prepper versus 19,000 with Logstash. We also created a small corpus of VPC, or maybe not a small, but a corpus of VPC flow logs that we put into an S3 bucket. And then we populated an SQS so that we could start loading these through Data Prepper and Logstash into two different OpenSearch clusters. We found that with Data Prepper, we were able to complete this in 40% of the time that it took to do in Logstash. So what this translates to really is that you can cut down your compute costs. You can run perhaps half the number of nodes, or perhaps use a lower cost EC2 instance or whatever infrastructure you're using. I do want to talk some about how we can get started with Data Prepper. So if you haven't used it, I definitely encourage you to try it out. We have a lot of great example projects. So we have some projects that will kind of guide you through using some of these things we talked about today, such as the trace analytics setup and also logs. So start with some of the example projects. Data Prepper is a standalone application, and it does have a different release cycle from OpenSearch. So you can get it as a Docker image, you can get it as a tar.gz file, or you can build it from source if you want. I also encourage you to read the documentation. We've put together some great documents, and a number of them actually start with the idea of these use cases. So if you want to use Data Prepper, for example, with trace analytics, we have a document to help you get started with that. We also have some great reference documentation so that as you're configuring your pipeline, you can understand well how to do it. We also encourage contributions. If you try out Data Prepper and have some ideas, please create a GitHub issue. Let us know what you're looking for. We're really happy to hear from the community. And then if you want to contribute code, we're really excited about that too. We would encourage you to create a GitHub issue, and we would really like to help you get started. We could point you in the right direction for what to do, work with you on the design, and we're happy to review your PRs. I think I have a few more minutes. So in that time, I do want to talk about some of the upcoming features we have with Data Prepper. In our next release, 2.5, we're going to release a new OpenSearch source. This source was specifically tailored with migrations in mind. So if any of y'all were in Willow yesterday morning at the partner conversation, we heard that a lot of the partners were talking about how OpenSearch migrations are really difficult. Well, we're working to help with this by using Data Prepper to read your OpenSearch data from one cluster and pull it into another. We're supporting reading from OpenSearch 1.0 clusters as well as Elasticsearch 6 and 7 clusters. Later this year, we're going to also release a DynamoDB source. This is going to use change data capture so that you can start to get data out of DynamoDB and perform searches on that data. This is getting us more into that search use case and a little bit out of just analytics. We also have some plans to add similar capabilities for MySQL, Postgres, and DocumentDB or MongoDB shortly after that. Now, Krishna talked about using Kafka as a sink and a source. And so one of the thoughts we had was, hey, can we use Kafka as a buffer so that you don't really even have to think about, okay, I need to send to Kafka and then to Data Prepper. And instead, if you have a Kafka cluster and a topic, you can configure it so that you can still just write your logs straight to Data Prepper, and then Data Prepper will put it in that Kafka buffer and read from that buffer so that you can get Kafka persistence, but without having to think about having multiple technologies. And we believe it is a great time for you to start using Data Prepper, and I really thank you all for coming and listening to our talk. We've had a great time speaking with you. Krishna and I will both be around at the conference. Come find us later, ask us your questions. We're really happy to talk. And I hope you enjoy the rest of your day at OpenSearchCon.